In today's video, we're going to be covering graphs and functions, which accounts for 25% of your total GED questions, or about 11 or 12 questions. Compare the table and graph. Which function has a positive slope? So rather than use the word slope, I'm going to replace that word with the word rate. Think of rate as how much that changes per or divided by how much the x thing changes. Now, in this question, they don't give us any real life context for x and y, but they do give us some details showing how in specific cases, x and y are related. So let me explain what I mean. On the left side, we have what's called a table, which is a way of organizing data points, and they come in pairs. And you'll notice that the first column is labeled x, the second column is labeled y. And what this kind of means is like whenever x is -3, y is 2. Whenever x is -1, y is 6, and so on. Right next to it, we have a graph, which looks kind of like a grid. Similar to the table, where each row is a pair of numbers, used parentheses to pair those numbers together, 2 and 4. I used a comma to separate the two numbers. So in that graph, we have our x-axis and we have our y-axis, and then we have that diagonal line, as I was kind of referring to, with those points along that line. So the line itself is a visual for how x and y are related to each other. And when you pick a single location along that line, like I did there, you can see a specific case, say when x is 2, y is 4. Contained within that line is the same information that you might find in a table. It just looks very different. Okay, so to calculate what they call the slope and what I like to call the rate or rate of change, let's call back to mind that phrase in English for a rate, specifically the word per. And in specific examples I've used already, $3 per gallon, $12 per hour, $2 per gallon of milk. There's two things that are related on either side of that word per. The first number represents the y number, whatever y is abbreviating, in the algebra language. And the second number is abbreviating x within the algebra language. And so to calculate the specific rate value or the slope value, what we need to do is we need to find out how much the y abbreviation or the y value changes from one point to another point, and then compare that to how the x number changes from one point to another point. The word per is translated to division, how much the y numbers change divided by how much the x numbers change. And we only have to use two pairs of numbers. So when you're given more than two pairs, like say in this table right here, pick out the two pairs of numbers that look easiest to you to calculate with. For me, when I'm looking at this, I'm seeing the third and fourth row as being both like all positive numbers and fairly small. I like to use positive numbers if I can, so that's what I'm going to do. So for the y, how the y numbers change, we're going from, say, 10 up to 14. That's a change of positive 4. It's going up 4. And then the x numbers go from 1 to 3. So that's a change of 2. It's going up 2. And we just divide those things to get our slope or our rate. And 4 divided by 2 is equal to 2. So the rate of change, according to the table, is positive 2, meaning the y number increases by 2 every single time the x number increases by 1. Okay, so now let's take a look at the graph. And I've relisted the location of the point that I had earlier on there. If we use this one and that one, we're going from 10 down to 4 for how much the y numbers change, from 10 to 4. Now that one's actually going down, right? And it's going down by 6. So I'm going to use -6 to indicate that it's decreasing or it's going down by 6. Then I'm going to divide that by how much the x numbers change, which the x numbers go from 0 to 2. So that's actually going up 2. And if I do negative 6 divided by 2, I get negative 3. So that slope or that rate of change is negative 3, meaning every single time x increases by 1, y goes down by 3. So it looks to me like the table has a positive rate of change at positive 2, whereas the graph has a negative rate of change at negative 3. So only the function in the table has a positive slope. That's true. That's the answer. Which relation is not a function? So if you know specifically what they're asking you for here, this is kind of like a yes or no question, and it could also be a 10-second question if you know exactly what to look for. So here's what you're looking for to determine whether something is a function. Every x number that is given in the set has to be paired to one and only one y number. So let's take a look at all of our x values in answer choice A. In answer choice A, we have 1, 2, 3, and 4 for my x values. And you notice I was just looking at the x's. I didn't even pay attention to the y's. And since each and every one of those x's is a different number, then I know already that that one's a function because it meets the definition that every x is paired to only one y number. Essentially, none of the x is repeated. So now let's look at B, and B is the same case. C also has, oh, wait a second, right there. C is not a function. So that means whenever x is equal to 1, we don't know if we should pair that with a 7 or with a 9 for its y value. That means that C is the correct answer here. Which point on the graph represents the ordered pair negative 6, comma, negative 8? Okay, so fortunately, we've seen this way of organizing numbers in the previous two questions. So we have already touched on the fact that the first number is an x number and the second number is a y number. Now, on the graph itself, we want to start at the location where the x-axis and y-axis meet, called the origin, and then use these numbers provided to get to our answer. So that means we need to go negative 6 for the x and then negative 8 for our y number. And so wherever those two things meet up is the answer, which is answer B here. Given the function f parentheses x equals 3x squared plus x minus 4, complete the following table. So the hardest thing about this question, honestly, is the unusual way that they're asking us to do this question, which is using a very specific type of symbol called function notation. And they're giving us a table that is kind of organized left to right rather than up and down like most tables are. So those things are a little bit disorienting. But let's talk first about what's called function notation. We have the letter F next to the letter X, and the X is in parentheses. So this is actually not multiplication. This is called function notation, where the letter F is the name of the function rule. The letter X is the changeable value of the equation. And when x is negative 2, what that would look like would be like this. F parentheses negative 2 equals, and then every time we see an x, we would change that x to negative 2 and solve it. So I'm going to write that out, and then we're going to solve that very first case. So the left part of the equation is just really there for show, or just to indicate that we've changed all the x's to negative 2. We don't have to do anything over there. What we really need to focus on actually is just solving the stuff to the right of that equal sign. So the first thing we want to do is tackle the exponent part of it, which is this little 2 up here. And that means that whatever it's next to, we need to take that thing and times it by itself. So we just do negative 2 times negative 2, which is positive 4. And then we take positive 4 and times it by 3, which is 12. Now for the next part where it says plus negative 2, I'm just going to write minus 2, because it'll basically means the same thing, and then minus 4. So 12 minus 2 is 10, minus 4 is 6. When x is equal to negative 2, the outcome is 6. Using that information, we can rule out a couple answers here. We know it's not B or D. Okay, so I just basically erased everything and changed all my negative 2's to 1, and we're going to solve it again. So 1 to the second power means 1 times 1. 1. And then 3 times 1 is 3. So 3 plus 1 is 4. Minus 4 is 0. So when x is equal to 1, the outcome is 0. So that means C is our answer. Which of the following represents the equation of a line that is parallel to the line represented by the equation y equals negative 6 times x minus 27? What you see now in front of you is commonly referred to as the slope-intercept form of an equation. It's a helpful structure, though, to keep in mind, especially for these types of questions where you have a y and an x that are related to each other somehow, and that algebra equation demonstrates how to get from one of those values to the other one. Okay, so why go into all this then? How does this pertain to, or how does this relate to this question specifically? Parallel lines are two lines that run next to each other, but they never cross. Parallel lines have the exact same rate of change or the same slope. So what we want to look for is the equation which shows the same slope as the one that they've given us. So in the instructions, the slope or the rate of that equation is the number that's multiplied by x. So the rate according to the equation in the instructions is negative 6. So we just need to find an equation that also has the same rate of negative 6. And that's right here with letter C. Letter C has negative 6 times x as well. So both the equation in the instructions and answer choice C have the same rate or slope, whatever word you want to use, which is negative 6. It's the number that's multiplied by x. Suppose plane A flies 500 miles in 1/2 hour. Plane B, flies according to the function f parentheses x equals 350 times x, where x is the number of hours traveled and f parentheses x represents the total distance traveled. Which plane is faster on average? Okay, this can be a pretty quick question. Maybe not a 10-second question, but pretty quick. Let's go back to something I mentioned earlier when we were discussing this notation. I mentioned how you can change it to the letter y and have it basically mean the same thing. This is a perfect example of when that would be to your advantage to change it to y. Because by changing it to y, we now have y equals 350 times x. And from the last couple questions, we've seen how whatever the number is that's multiplied to x, that's our rate. So I know that plane B is traveling 350 miles per hour. Now to get how fast plane A is traveling, it says that plane A travels 500 miles in 1.5 hours. So that would kind of look like this: 500 miles per 1.5 hours. But we want that to be miles per hour, per 1 hour. So all we have to do, instead of saying 500 miles in 1.5 hours, we just divide it. We do 500 divided by 1.5, and now we have our miles per hour, which for plane A is 333. Just ignore all those 0.33333. It doesn't matter for this question. So basically the speed is 333. Plane B is 350, so plane B is traveling faster. All right, that'll bring us to the end of this question set. Thanks for your attention, and keep up the hard work. Let me know if you have any questions, and I hope this was helpful for you. and we'll see you in the next video.